Okay, so here's a solution set for number 57, and this is definitely excellent. If you can cope with this, you've got the algebra sorted and in a good position to hopefully do well in the real life context of the assessment based question. Okay, so the key thing, as it says here, investigate the nature of the solution set, and you have to justify any conclusions, right? Now, let's just flip the page here. So there's the answer, by the way. Okay. Definitely excellence this. And read question carefully. For the solution to be inconsistent, demonstrate that the resulting system of equations are then. So first of all, you have to calculate a value for the coefficient x so that solutions to the three equations are inconsistent, and then demonstrate that they're inconsistent. So you need a false statement. Okay, 0 equals non-zero. And so usual story, let's go 1, 2, 3. But first of all, let's just take these equations and plug it into our friend Desmos. Okay, so at the moment, I've put that in as 1. The coefficient for A is 1. If we just, made that, I don't know, 4. Okay, what you're seeing here is you're getting a unique solution. But the question's asking you to put a value in here such that it's inconsistent, as in you get a false statement. So that is the challenging aspect. Okay, and to do that, what we need to do is algebraically solve it. So the strategy here is I've looked at this and let's look at the y's in here, okay? And let's eliminate y's. So let's just clear that up. So we're saying 2 times equation 2, 2x minus 2y plus 2z equals -8. Let's call that equation 4. Let's bring equation 1 directly below it and then go 4 plus 1. Why? Because we're going to eliminate the y's. That gives you 3x. That gives you 4z. That gives you -2. Let's call that equation 5. Now this bit's tricky because we're going to now do the second equation and we're going to have to cope with this bit in here. So what I've done is let's take equation 2 and directly put below equation 3. So no having to alter these because it's nicely set up. Can't quite see that. But it's set up, you've got minus y and plus c. So this is a nice problem. So if we were to add those together, because we want to eliminate that, you get x plus ax. And you get -8z, and you get -4 minus 1. That's -4 plus -1 is -5. Call that 6. So now, if we were to focus, we've eliminated the y terms. We've got this term up here, 3x plus 4z equals -2. And we've got okay, and this term in here. So what I've done is I've looked at equation 6 and I've seen there 8z. So I thought that's 4z. So I'm going to take equation 5 and times it by 2. So that gives me 6x. Just ignore that. Mistake by me. That gives me 8z, sorry. That's times by 2. That gives me -4. So now I have these two equations. And what I want to basically do is I want to add equation 6 and equation 7. And on this side, -5 plus -4 gives me -9. Now here, -8 plus 8 gives me, yes, that's what I want, 0. Now, for this to be a what? False statement. Okay, there we go. This has to be ... to be 0. So if I just add those together, I want you, as in to solve this, that has to equal. So let's just look at what's just happened. We've got x plus ax plus 6x, and we want that to force it to equal to 0. So let's just do some algebra here. What's x plus 6x? That's 7x, and then I've taken a common factor of x out, and what's left? 7 plus a. Now, solve it equal to 0. One solution is, well, x equals 0. Other solution is if a were to be equal to -7. So if we put -7 in here, that would be that would be -7. That plus that would give you -6. Adding on that would cancel out to 0. So that is the solution. Now, technically, it says demonstrate the resulting system of equations are then inconsistent. So if I just sneak into here, okay, so algebraically you could, how do you demonstrate this algebraically? So if you made a different number which wasn't -7, so for example 1, you would get a false statement. 2, -28, but if you put -7 in there, you will not get a false statement. So let's algebraically check this out. Let's go back here and replace that with -7, and whoa, what are we getting? There we have it, the famous Toblerone chocolate solution. So now you have those three equations. Just by changing that one constant a, you now have an expression. The three equations are inconsistent. That is a solid excellence.